All right, we're here at the bottom of page 3 for section 2.2. And we are going to look at one of the practice plus. So we're knowing now that we're going to take what we're learning in this section, which is to solve equations using addition and multiplication property of equality, and combine that with a previous skill. And you can see the problem we picked out. It means we're going to combine that with translating. Here's the instructions. Use the given info to write an equation. They continue to describe it. Then they recommend that we use x as our variable. I'm saying you can use any of your favorite letters. That doesn't matter to me, but they're just reminding you that there's going to be a variable involved. And then go ahead and solve. So there's two things that we're going to want to have in our answer. One is the actual equation that we translated, our translated equation, and then we're going to have our final solution. What number makes that equation true? So because we are in the section and the chapter about solving equations, we can expect when we have to translate here that we're going to translate to an equation, meaning there's going to be an equal sign involved. It's going to have an equal sign, and then we're going to have to solve it. Now the instructions say so. We come with that expectation because we're still in the section in the chapter that's been practicing that. And so it shouldn't be any surprise here. It's nice to come with some expectation of what you should get. It helps you catch any mistakes, keeps you down the right path. Let's do our read, breathe, read method here. -5 times a number increased by 11 is -29. Deep breath. Don't read it and then assume I can't, okay? If anything, after the deep breath, force yourself to tell your brain, tell your heart, I can do this. I can get through this. I can make this happen. I can get stronger. So -5 times a number, comma, increased by 11, comma, is -29. Those commas are important. The commas matter here. We went through this earlier in chapter 1. You can kind of flip back through your notes, go rewatch the video that lines up with that page. But commas matter here. And what we talked about was that commas, when you have something included in the commas here, when you read, you're supposed to pause for a comma. In fact, they talk about in literary terms that this is a kind of a parenthetical statement. It's kind of or I think they actually call it a positive, maybe. It's something that sets apart, something that is not a part of the original statement. So you need to set it apart in terms of your translating too. It comes after what was just described, okay? So let's look at what's described here, see what pulls out. Keywords. We know our goal. Our goal is to get to an equation. So we know there's going to be an equal sign. We know there's going to be variables involved. And then after the translating, we'll worry about solving. But let's get through the translating first. So -5, okay, I'm seeing -5 here, times, so I'm going to multiply, times a number x, okay? So I get to do all that. Then I'm going to increase it by 11. Increased by means we're going to add 11. There's my is, so that's my equal sign, is -29. So just in a quick verbal translation here, it seems like I've got -5 times a number x increased by 11. So after that happens, you could even, just to make sure you're totally safe here, after that whole thing happens, force it to go first with those parentheses. Then you'll add 11 equals -29. Okay, so a pretty straightforward translation. Then we kind of analyze it a little bit. Do we really need the parentheses? Well, order of operations tells us that we're okay to let go of these parentheses. It was good just as a safety net to make sure it got set apart from what was being told us in the commas, or what was being described to us. But because we've got multiplication here, order of operations dictates that that will come first ahead of the +11. So we're free to get rid of the parentheses and just write our final translation as -5 times x. And I'm going to use my algebra skill here. Less chiseling, less ink, less paper, less time. -5 times x can be written just next to each other, -5x, plus 11 equals -time. negative 29. So there's our translated equation. That's going to be in the back of the book. So you're going to look for negative 5x plus 11 equals negative 29. You're checking how you did on translating. Then you're going to turn around and apply your solving skills, and you can check that solution as well in the back of the book. Okay, so we start by checking for parentheses, because we're trying to simplify, and we're checking for like terms. And in this case, both of those are done for us. As we look on the left, no parentheses. On the right, no parentheses. Back to the left, any like terms? Nope. No matching variables with exactly matching exponents. On the right, just plain old negative 29, nothing to combine there. And then we make sure that x has picked a side, and it's only on one side of the equal sign. It's here on the left, nowhere else. We're good to go. Already been done for us with our superb translating skills, apparently. Okay, so then we ask what's happening to that x. So ignore the other side of the equation for this part. Ask yourself what's going on, and I'll say it again. I said it at the top of the page. If you can look at this equation and there's no doubt in your mind what you need to do first to solve it, then you don't need what I'm about to do, this what's happening to x, and then undo it by doing the reverse. But if you look at this equation and you're asking yourself, do I add the 5 or do I subtract the 5? Do I divide by the 5 or do I get rid of the 11 first? If there's any doubt in your mind what you need to do and what order you need to do it in, then do what I'm describing here. Create a what's happening list. And you have a choice. You can create it by actually writing out a verbal list of steps, or you can do the more visual timeline. Here's what the steps look like. If I plugged in a number for x, the first thing that would happen is it would get multiplied by a negative 5. The second thing that would happen is an 11 would get added to it. So our verbal list says multiply by negative 5, add 11. If you were to do a timeline to visually describe what was happening to x, you could take the x, show that it gets multiplied by negative 5, and then show that it gets added to 11, and we would read that left to right here on the visual timeline. Now our job is to undo it. So we go in reverse order up the steps of our original verbal list. So step 2 becomes our new first step, step 1, followed by our new step 2 as we go up the list, and each operation becomes opposite. So we subtract, we divide. Or if you want to use the timeline, just go right to left, and as you come across it, make everything opposite. So plus 11 becomes minus 11. Times negative 5 becomes divided negative 5. Notice the signs are the same. So the signs remain unchanged, or they remain the same. Okay? So positive, negatives stay the same there. Then we follow that prescription. You've created a list for yourself, or you've created a visual timeline here of what we need to do. As you go up the list, step 1 says to subtract 11. As you go across the timeline from right to left, the first thing you run into is a minus 11. So that's what we do first. Again, you don't have to do both methods here. Just pick the one that works best for you, either words or visual. So we subtract 11 from both sides, and we end up with negative 29 minus 11 is going to be a negative 40. The plus 11 and minus 11 cancel out. That was the whole point of this. And now we're looking at negative 5x equals negative 40. And again, if you've done this what's happening process and the undo process, you don't have to wonder what do you do next. You just go back to your list. We've done the minus 11. Now it says it's time to do divide by negative 5 because we continue right to left across the timeline. Or we go up the list. We've done the subtracting 11. Now it's time to divide by negative 5. Both lists tell you the same thing to do, so you pick the list that makes most sense to you, and it's easy for you to create. The negative 5s cancel out. That's the whole point. Division undoes the multiplication. And then negative 40 divided by negative 5 gives you a positive 8. You'll then check that back in your original equation, which for you, when you translate, you probably want to do a look back on the translation. I should have modeled that earlier, but negative 5 times a number increased by 11 after that is negative 29. So it does match up with what's written. So this is my original that I get to check in. So negative 5 times whatever I get for x plus 11, will that equal negative 29? So I'm going to take my answer of 8, and I'm wondering if that works here. So negative 5 times 8 is negative 40 plus 11. Does that equal negative 29? And it does. Negative 29 equals negative 29. This is a true statement. So I can go ahead and take my answer and put it in set notation here, an answer of 8. And these are what I'm checking for in the back of the book. Is my translation okay? And is my solution correct as well? Okay. And we'll see you on page 4. Good job.